Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a DC parallel circuit from the Chapter 7 math handout, problem number 7. So first, I am going to get my known values from the Chapter 7 math handout. As you see here, and we're working on number 7. I have it highlighted, and so I know it's going to be a random unknown because the handout tells me so. Plus, when I look at the known values given, I do not have all of the information that I need. One of the resistors is missing. So anytime a circuit doesn't list all of the resistors and the total voltage, you know that it's a random unknown. I am also using the Chapter 7 formula sheet. It's for Chapter 6 and 7 and 8 actually. So here's the rules for series, here's the rules for parallel. This is our series parallel rules sheet. And I have went ahead and clipped out our rules for parallel that you see right here. And it is very important to understand these rules very well in order to be able to solve these problems and to calculate all of the values for the circuit. So we see here the values we were given 3 resistor values, 1 current, and 1 voltage. Alright, so I see my given values here, and the first thing I'm going to do, if I understand my parallel rules well enough, I look here and the rule tells me I can fill in all of my V's because V stays the same throughout the circuit. So I'm going to go ahead and fill in all my V values. They're all 36 volts. All right, now my next step, all my V's were done. My next step, I'm going to find I2, I'm going to find IT, I'm going to find I1, and I'm going to find I2 because we have enough information to calculate all 3 of those components. So I2, I cover up the I, cover up the I, and it's V divided by R. So I take the V, 36 volts. I hit over under, I enter the 360 ohms. It equals, hit engineering, and I have 100 milliamps. But current, if we look at our current rule, it does not stay the same. So each one of these currents will have a different value, and that's why we have to calculate each one individually. Alright, I1, I cover up the I1 is equal to V over R, so I've got 36 volts that will be over 1.2 k ohms. I've already got my 36 in there, so I'll just scroll up, remove the 360, and I'm going to put in 1.2 k ohms. Equals, hit engineering, and that's 30 milliamps. Alright, next I'm going to say 36 volts divided by 1.8 K. Scroll up here, change the 0.2 to a 0.8, and that would be 20 milliamps. Alright, doesn't look like I can go any further. I could solve for R3 right now, but that's not going to help me because I'm still stuck here on current. So what can I do? So I'm going to leave resistance till last, and then after we do resistance, we'll do power. So the way that I actually can find I4 is, if you look here on the steps, bottom right of your screen, this formula right here, I4 is equal to IT minus I1 plus I2 plus 3, I'm sorry, that should be a 4. But I do have the formula here for you as well. I4 equals IT minus I1 plus I2 plus I4. Looking for, I made a mistake there as well. Let me fix that. Sorry, guys. I3, nope, it is I4. All right. I4. And this one's right too, it is I4. All right, sorry about that. So we subtract 20 and 30 and 15 from 100, and whatever is left over is the value of I4, 35 milliamps. Now we can use Ohm's law to find R3. If we look at our circle, we cover up the R, and you have the V over the I. We do have the V, we do have the I, so we'll take the 36 volts, and we'll divide the 15 into the 36. So I got 36 over 15 milliamps times 10 to the negative third equals, hit engineering, 2.4K ohms. Next one's the same thing. I cover up the R. I see that I would have V over I. So I take the V of 36 volts and I divide 35 milliamps into it. And that equals 1.03 K ohms, rounding the second number after the decimal place. All right, now we can do power. So the first thing we can do to find PT, we take the IT times the VT. So I have 36 volts, put that in first, times the 100 milliamps gives me 3.6 watts is my total power. Next, I'll do P1, so I just need to change the 100 milliamps to 30 milliamps. And that gives me 1.08 watts. Next, I'll change the 20 milliamps to, I'll change the 30 milliamps to 20 milliamps. So I scroll up here, get to the 30, delete him, put the 2 in, so that's 20 milliamps. P2 is equal to 20 milliamps times 36 volts. That's what we have here. And that gives us 720 milliwatts. All right, for P3, I3 times V3. Got the V3 right here. And I'm looking at 15 milliamps. So I want to scroll up here, get rid of the 20, and put the 15 in. And that gives me 540 milliwatts. Next is P4, our final calculation. 36 volts times 35 milliamps. We'll go up here and change it to 35 milliamps. And we get an answer of 1.26 watts. So now that we have calculated all of our values, we can see here, these are the questions that you will be asked for on the Canvas answer sheet assignment for Chapter 7 math handout. Got them ready to enter. And as I say, I recommend doing all of these circuits on paper first, getting all your answers written out, and then open up the homework assignment and try to complete it. But I know you won't try to. I know you will. I know you will get it done because you are a great student, all of you. All right, I hope this helps you out. Thank you very much.